Okay, so for this week we're going to do discrete probability distributions. So I'm going to quickly go through the definitions here and then do some examples. So we have a random variable x represents a numerical value associated with each outcome of a probability experiment. Discrete random variable has a finite number of possible outcomes. Continuous random variable has an infinite number of possible outcomes. You can kind of remember it. Discrete is usually the counting numbers like 0, 1, 2, 3, 4. Continuous has decimals is how the easiest way to remember it, and is a good rule to follow. So if you want to decide if the random variable is discrete or continuous, for the number of players on the basketball team, you can't have just like half a player or a fourth a player. Either you have a player or you don't. So that would be a discrete value. There's a finite number of players on the basketball team. Length of time it takes to swim 4 laps in a pool. Time is always continuous. It can be decimals. You can measure time in an infinite number of ways. So it includes the decimals. So that's how I remember it. If it can be decimals, it's continuous. If it's not, then it's discrete. The number of daffodils planted in a garden. Either you have a daffodil or you don't. So that one would be discrete. The height of 7th graders. That one, the height is actually continuous. Height and weight is continuous because you can have decimals when you measure, and there's different ways to measure heights and weights. So that one is continuous. So we're going to focus on discrete probability distributions. So that lists each possible value of the random variable x together with its probability. Properties of a probability distribution, you'll see this in just a minute when we get to an example. The sum of the probabilities has to be 1. If it doesn't add up to 1, it is not a discrete probability distribution. And all of the probabilities have to be between 0 and 1 inclusive. If that's not true, then it is not a discrete probability distribution. So these two things have to be true in order to make it a discrete probability distribution. To find the mean, you can use this formula. You can also use the calculator. So when I do the first one, I'll show you how to do it on the calculator. I'll show you how to use the formula, but it takes a long time to do the formula usually. So calculator would be the easier way to go. The mean's not so bad. The variance is a worse formula. So for the variance, like I said, I'll show you on the first one, but then we'll just use the calculator. Standard deviation, to find the standard deviation, you just take the square root of the variance. When we do these on the calculator, it's similar to a frequency distribution to do these on the calculator. So I'll show you both ways, and then we'll just use the calculator. If I can turn the page maybe. Okay, so this is an example of a probability distribution here. A survey asks a sample of families how many TVs are in their household. So you have a sample of families. They have either 0, 1, 2, 3, or 4 in their house. The probability of each is listed next to it. So that is a probability distribution. And here's a picture of the graph if you want to see that. It says determine if it is a discrete probability distribution. So the two things that it has to be in order to be discrete is it has to have, the probabilities have to add up to 1, and they have to be between 0 and 1 inclusive. So if you take this and add them up, 0.12, 0.11, 0.38, 0.26, and 0.13, they do in fact add up to 1. So the sum of p of x is 1. And all of these numbers are between 0 and 1 inclusive. So if both of those things are true, then yes, it is a discrete probability distribution. So to find these values, to find the expected value, if you look back at the first page, expected values, here is your mean. So like I said, you can do it with the formula or you can do it on the calculator. I'm going to start on the calculator and then I'll do the formula. So the expected value is your mean. Your standard deviation for probability distributions, it's a population always. And your variance, so you're using population symbols. So to do this on the calculator, so we'll start there. So let me go over here to my calculator. So we go to Stat and Edit. Oops, let me do that. And let me clear out out these lists. So in L1, you type your X values. So we have 0, 1, 2, 3, 4. And in L2, you type your P of X values. So 0.12, 0.11, 0.38, 0.26, and 0.13. So it's like when we did the frequency distributions using midpoints and frequencies, same idea. So once you have that in there, hit second mode and get out of it. And to calculate the mean, you go to Stat, Calc, same place we always go. Choose the first one. And we're using two lists, so we do second L1, comma, second L2. The calculator knows for this one, because the probabilities add up to 1, they're 100%. It is a population because of that, so the calculator will only give you sigma because it knows as long as those values add up to 1, it knows that that's talking about a population. It still says X bar because it doesn't switch to mu ever, so you just have to know to write down mu. So like I said, we had our stat. We had our list, and I've hit one wrong. My number was a little off, 0.11. Sorry, 0.11. Okay, now let me go back and do that again. So I'm just going to hit second enter, so it'll do the same thing, but I just did. There we go. So we have this X bar as our mu, and this sigma is our standard deviation. So we come over here, so we have mu is 2.17. Sigma, if we round to 2 decimals, is 1.16. And to get sigma squared, same thing like always, you don't want to use the rounded one, you just want to type that number out. So 1.15805872 and square it, and then round to 2 decimals is fine, you get 1.34. So that's using the calculator, which is the faster way. So I'm going to flip this over for just a minute just to show you one using the formula so you can see. So your expected value formula is the sum, get back to my page here, is the sum of X times P of X. So if we take X times P of X, so I just have it listed down. So we have the first one, I've got another printout here, so I'm going to just do this. So the first one is 0 times 0.12, which is 0. The second one is 1 times 0.11, which is 0.11. 2 times 0.38 is 0.76. 3 times 0.26 is 0.78, and 4 times 0.13 is 0.52, and then we add those up. If you add all of those up, you get 2.17, which is the same thing we got on the calculator. So that formula is not like horrendous or anything. It's not too bad. To do the variance, however, it's a little bit worse. There's two variance formulas. I use the second one listed on the front page. So it's the sum of x squared times p of x. And then once you have that, subtract mu squared. So we do, for our x squareds times p of x, the first one you would have 0 squared times where'd it go? 0.12, so 0 squared still just 0. So the second one you have 1 squared times 0.11, which is 0.11 still. Then you have 2 squared times 0.38, which gives you 1.52. Then you have 3 squared times 0.26, which gives you 2.34. Then you have 4 squared times let's write it down, 4 squared 0.13, which gives you 2.08. So this formula, because the x is 0 through 4, isn't so bad, but you can imagine if you have x is 0 through 30, that it would take a really long time to do this by hand. So add these up, so we would get 6.05. So the sum of x squared times p of x is equal to 6.05. So that's this part of the formula. So for the other part, we need mu squared, which is 2.17 squared, which is 4. And for this, don't round until you get done. So 4.7089. So to find sigma squared using that formula, we take this number here, that piece, minus this piece. So we do 6.05 minus 4.7089, and that gives us 1.3411, which if you flip back to the calculator, I still have it here, 1.3411 if you round that up. So it's the same. The calculator is more accurate, so it has more decimals than what we have, but if we round to 2, we get the same thing the calculator got. And sometimes when you do this by hand versus the calculator, you may have 1 decimal off when you round. It may be 1.33 or 1.35 or something, which is okay as long as you're close. And then to do sigma based off this, you do the square root of the not rounded version, which gives us 1.158 or 1.16, which is what we got on the calculator. Oh, it's still on the calculator here. So 1.158 or 1.16. So you do get the same answer using the formula as using the calculator, but like I said, the calculator is much faster, especially for x 0 through 4, it's not so bad, but if you go 0 through 30 or 0 through 50 or 100 or whatever, you don't really want to do that by hand. Okay. So for example 2, you have the following table lists the number of peas with green pods among 8 offsprings. Determine if this is a discrete probability distribution. So all this 0 plus means is that it's so small it doesn't matter, you just count it as 0. So when you put it on the calculator, you type it in as 0. So if we add all of these up, they have to add up to 1, and they all have to be between 0 and 1 inclusive. Those two statements are both true, you can check it. So the sum of p of x is 1, and all the probabilities are between 0 and 1, so yes. To do the expected value, standard deviation, and variance, I'm not going to do these by the formula. You do the same way as here, I'm just going to do them on the calculator. So go to your calculator. One keeps cutting off on me. Go to Stat and Edit. Oops. I've already got 0, 1, 2, 3, 4 typed in, so I just need to add, if I can get down there maybe, 5, 6, 7, 8. So 5, 6, 7, and 8. For L2, I'm just going to type over that. So 0 plus, like I said, you just put it in as a 0. It's so small it doesn't matter. So 0, 0, and then 0.004. And then 0.023, 0.087, 0.208, 0.311, 0.267, and 0.100, so it's just 0.1. And then once we're done, we can get out of there, second mode, go to Stat, Calc, choose the first one. You're using 2 lists, so do L1, comma, L2. Hit enter. So there's our mean and our standard deviation, and then we can find our variance. So our expected value, or our mean, is 6. Our standard deviation is 1.22, and we'll just round to 2. To get the variance, again, don't round, type it out, 1.2222, 92927, and hit squared. So that's 1.49. So there's your expected value or your mean, standard deviation, and variance using the calculator. And so you can check it on the formula, it'll work if you want. Use the range rule of thumb, which we learned about a couple weeks ago, to identify the usual number of P's with green pods. So the range rule of thumb says that most data values fall within 2 standard deviations of the mean. So we would do mu minus 2 sigma is our min, and mu plus 2 sigma is the max. So in this case, we've got 6 minus 2 times 1.22, and then 6 plus 2 times 1.22. Calculate both of those, you should get 3.56 and 8.44. So it says, based on this result, is it unusual to get only 1 P with the green pod? So is 1 between these two numbers? No. 3.56 to 8.44, 1 is not, 1's below it, so you would say yes, it is. For the probability, to find these probabilities, when we do probabilities, you're going to have to write the probability statement. So you're going to do the probability of getting exactly 7 P's with green pods. So this section you have to actually translate words into math, into numbers. So exactly 7 means x equals 7. The probability that x equals 7, go look at your chart, it gives you a chart, so use it. Here's 7, the probability is 0.267. Find the probability of getting 7 or more P's with green pods. So 7 or more means greater than or equal to 7. So that would be talking about, based off this, you'd be talking about 7 and 8. So the probability would be 0.267 plus the one for 8 is 0.1, which is equal to 0.367. The probability of getting less than 4. If we do less than 4, it's strictly less than 4. So we do not include 4, so we're only looking at 3, 2, 1, and 0. So we're talking about adding up these numbers. So 0.023 plus 0.004 plus the 0 pluses, which are just zeros. We're not going to worry about them. So that one is 0.027. So if you're given a chart to find the probabilities, you just use the probabilities on the chart and you add them together, or you just get the value, and that's how you find your probabilities. So we also have what's called a binomial distribution. So a binomial distribution has to satisfy these following conditions. They have to be a fixed number of trials, which is denoted by a lowercase n. They have to be independent and repeated under the identical conditions, so it cannot depend on each other. Each trial has 2 outcomes. It's a success, which is denoted by a capital S, or a failure denoted by a capital F. Now, it doesn't mean that success is something good and failure is something bad. It just means success is whether or not whatever it is you're talking about happens, and failure is whether or not it doesn't happen. Probability of success is denoted with a lowercase p. Probability of failure is denoted by a lowercase q, and p plus q always has to equal 1. X is the number of successful trials, so if you have 30, you would go 0, 1, 2, 3. It counts the number of possible successful trials, so up to 30. If there was 60 trials, it would be 0 through 60, and so on. You do need to remember that x and p must both refer to the same outcome, so we'll talk about that when we do the example. To do the mean, the variance, and the standard deviation, these formulas are a little bit easier. Mean is n times p, variance is n times p times q, and then the standard deviation is just the square root of n times p times q. So these formulas are nicer. So an experiment in which a basketball player who historically makes 80% of his free throws is asked to shoot 3 free throws, and the number of free throws made is recorded. Is this a binomial experiment? Why or why not? So you have to look, does it meet these conditions? Is there a fixed number of trials? Yes, he's going to do 3 of them. Are they independent of one another? That is also yes, because he's either going to make it or he's going to miss it. Whether or not he makes the first one has nothing to do on whether or not he makes or misses the second one. Has 2 outcomes. That's true. He either makes it or he misses it. And then your probabilities, he generally makes 80%, so he probability of him making it would be 0.8, and probability of him missing it then would be 20% or 0.2, because they have to be 100% or 1. So for all of these problems, I'm going to go ahead and set this up this way, because for all of these problems, I find it helpful to list this information on the side. So S, F, P, Q, and N. So success would be that he makes it. And you can change that. You could make success be that he misses it. It doesn't matter, but generally you pick whatever the problem's talking about. Failure is that he misses it. Your P, if he generally makes 80%, that's where you get, the problem's going to give you a P. P and Q have to add up to 1, we already said, so 0.20. And N, it's going to tell you how many times this is going to happen. So for all of these problems, it's easy if you do this, because then when you actually go to calculate stuff, you've already got it listed. So is this a binomial experiment? Yes, it met all those conditions. We didn't talk about X yet, but we'll get there in just a minute on part B. So on part B, it says identify the number of trials. Well, I just did that over here. It's 3. He's going to shoot it 3 times. The probability of success, I've also already done. He generally makes it 80% of the time, so 0.8. The probability of failure, we did. They have to add up to 1 or 100%, so 0.20. And all the possible values of X. So if he's going to shoot this 3 times, he can either make it none. He can make 1, he can make 2, or he can make all 3. So your X would be 0, 1, 2, or 3. Find the mean, variance, and standard deviation. That's just using these formulas here. So our mean is N times P, which we have in 2 places now. So 3 times 0.8 is 2.4. Our variance, I'm going to do it next just because that's the way the order goes, is N times P times Q. So 3 times 0.8 times 0.2 is 0.48. And the standard deviation is the square root of that. So the square root of 0.48 is 0.69. So that's using the binomial distribution and using those formulas. So we're also going to calculate probabilities for those on the next page. For the next problem, it says a probability experiment in which 3 cards are drawn from a deck without replacement and the number of aces is recorded. Is this a binomial experiment? Why or why not? So the key for this one is, if you are not putting the cards back, just like when we were calculating the probabilities, when we were doing the marbles, if you draw a marble out, you had 50 in the bag, and then you don't put it back, then you only have 49 in the bag. Those are dependent, because whatever you take away first, it changes the probability of getting something on the next go. So the same thing here, if you take a card out, if you draw out an ace or something, and you don't put it back, then that changes the probability of you getting another ace on the second time. So this is actually a dependent problem. So this is not a binomial distribution, because it has to be independent. If you were putting it back, it would be independent, but since we're not putting it back, that it makes it dependent. So, to actually calculate probabilities for binomial distributions, we're going to do 3, and then you'll have homework that does this, and there's another sheet that has answers. I don't have a video, but it has answers so that you can use it to help you on the homework as well. We'll be using the calculator. Ignore this on your notes. This chart's actually wrong. I had to find a different one. I changed that link, so there's a new link on yours. There are charts that give you probabilities for binomial distributions. Thing is, they do not have every N value in existence. You know, you can have, you know, a million number of trials. You can have 563 trials and stuff. They also do not have every P value. So your probabilities, there's not charts that list every possible value. So some cases you can use a chart. Other cases you're going to need the calculator, because the chart doesn't give you the information. Now on my old TI-83 Plus here on the calculator, I think this is actually, this one's 0 and this one's A, so let me just make a note. I'm not sure if on the TI-84 if it's A and B, but anyways, just pay attention to this part. So on the calculator, you'll do second vars. If you have an equal to, you'll choose the PDF, and it's a binomial, so binom PDF. If you have less than or equal to, you'll choose CDF. Now, you don't see a greater than, you don't see a greater than or equal to, or a less than, or a not equal to. That's because the calculator can only handle equal to and less than or equal to. It cannot do anything else. So that's what I was saying. You have to be able to translate these, and you have to be able to rewrite the statements to include an equal to or less than or equal to. So we're going to do all of the possible ones here between these three examples. So, according to research, about 70% of the households have cable television. And like I said, it's easiest if you write this on the side to start with. So we're talking about whether or not people have cable. All these questions ask about something about having cable. So success will say that they have cable, and failure would be they do not. And like I said, success and failure are just the terms used. Does not mean you're a failure if you don't have cable. That's just the terms we use. So the probability of you having cable, it tells us here, is 70%. Which means the probability of you not having cable, it would be 70%. You got to get to 100, so it'd be 30% or 0.3. And in each of these problems, it doesn't tell you up here, but it says in a sample of 15. So in our sample, we're going to do 15. Now I'm going to show you on this one how to do the chart and how to do the calculator, just so you can see both. And like I said, sometimes you may be able to use the chart, other times you won't. So in a random sample of 15 households, what is the probability that exactly 10 have cable? Exactly 10 means the probability that X equals 10. So if we do the chart first, a lot of people like the chart because the calculator can be kind of hairy. So if you go to the link on your notes, it should take you to this page, and I've already scrolled down here to where I need it to be. So you have to find the n value you're talking about. So for this one, we're talking about n is 15, which is over here. But like I said, like this skips 13 and 14. So if we were using those, we wouldn't be able to use this chart. And then we're going to do the probability that X equals 10. So your X, they call it an R, but we use X here. Your X is 10. So you go down to 10. And then you have to go over to where the probability is 0.7. So you can see up here the P's, you have 0.01, 0.05, so on and so forth. But like if you were doing 0.68, that wouldn't be on the chart. So that's what I'm saying is some stuff's not on the chart. This one is. Go over to 0.7, it should be 0.206. So I have it highlighted there so you can see. To do that on the calculator, if you look at the calculator notes, if you have an equal to, you're going to go to second vars and choose binom PDF. So we go to second vars, scroll up or down, whichever way you're going to go, choose binom PDF, and then you always type it in this order. You type n first, so our n is 15, and this is why I say write it down, because then you already have it, comma, p's next, our p is 0.7, or 0.70, 0.7, and then whatever your X is. So in this case, we're talking about 10. So basically whatever's in that parentheses with your X, you type next. And we still get 0.206. Now the calculator is more accurate, so it does more decimals, but it's still the same if we round. Usually these are always rounded to 3. So 0.206. So for part B, what is the probability that fewer than 13 have cable? Fewer than 13 means less than 13. Now you can use the chart, and I did. I'm not going to add it up again, I'll just tell you what it was. If you use the chart, here's 13. Let me highlight this. And go over to 0.7, maybe if I can. Passed it up. Here we go. So fewer than 13 means you're talking about 12 and below. So you would add up 0.17, 0.219, and so on, so on, so on, and up through here. So if you do it from the chart, you should get 0.874. So let me just write that over here, 0.874 from the chart, if you add up those values. On the calculator, however, if you look at the calculator notes, the calculator can only do equal or less than or equal. So it can't do less than. So you have to change this to a less than or equal to. If you're talking about numbers strictly less than 13, you're talking about 12, 11, 10, 9, and so on. So this is the same thing as the probability that x is less than or equal to 12. Once you have the less than or equal to, then you can do the calculator. In this case, you choose CDF. So you go to your calculator, you do second vars, go to binom CDF, because it's less than or equal to. N is still 15, P is still 0.7. This time though, our x is not 13, so don't use 13. We changed it to 12 because we needed less than or equal to. So we do 12, and you get 0.8731, yada, yada, yada. So the decimal on the calculator is more accurate. So if you use the chart, you would have gotten 0.874. But on homework, if you use the chart and you're one decimal off, I'm going to give it to you. You'll usually be 1 or 2 decimals off, chart or calculator, because the chart has rounded values. So either way, you get the same answer. For part C, what's the probability that at least 13 have cable? At least means can't be less than 13, so you're greater than or equal to 13. So on the chart, you can do that if you want. Here's 13. You greater than or equal to 13, so you'd add up 0.092 plus 0.031 plus 0.005, and you should get 0.128 if you add these up. So you would get 0.128 from the chart, which is acceptable. That's fine. I'm just going to show you how to do it on the calculator too. So for calculator, it has to do equal to or less than or equal to. You can't have greater than or equal to. So anytime you have a greater than or equal to, you're going to do 1 minus, and you have to change it to less than or equal to something. And the calculator can handle 1 minus binom CDF or 1 minus binom PDF. It's fine. So some people find it helpful. We have 12, 13, 14. So we want 13, 14, and 15. We want these numbers up here, which means we need to get rid of all these numbers down here. So if you have a greater than or equal to, you're going to do 1 minus the probability that x is less than or equal to 12 in this case. Because we just want these values here, we need to get rid of 0 through 12, essentially. So on the calculator, you will actually type 1 minus and then go to second vars and do binom CDF and do 15, 0.7, 12. So on the calculator, you can do that. You can do 1 minus second vars binom CDF 15, 0.7, 12. And you get 0.127. So again, the chart's off by 1 decimal, but it's still close enough. So you have to remember on the calculator for greater than or equal to, it's always 1 minus, less than or equal to, and go down by 1. Okay, for the next problem, you have, according to United States crime, the crime in the United States in 1998, about 60% of murders are committed with a firearm. And you're going to look at 14 murders randomly. So again, we want to write down our SF, P, Q, and N. So our success, it's talking about percent of murders committed with a firearm. So this is with a firearm. And again, success does not mean good and failure does not mean bad, because obviously if there's a murder, it's not good either way. But success will be with a firearm, failure will be without a firearm. Our P, it says 60% are committed with one, which means Q is 40% or 0.4, because they have to add up to 1 or 100%. And we're going to look at 14 murders, so N is 14. Find the probability that exactly 13 murders are committed with a firearm. Now, if you look on this particular chart, there is no n equals 14, so we wouldn't have the option of using this chart. You can probably find a chart that has that and you would be able to use it. I'm just going to do it on the calculator. So if we do equal to, that's binom PDF is equal to, type in n, which is 14, comma p, which is 0.6, oops, wrong button, 0.6, comma x, which we're doing 13, and we get 0.007. So binom PDF, because it was a equal to, and do n, comma p, comma x. The probability that 8 or more are committed with a firearm is x is greater than or equal to 8. Again, calculator can't do greater than or equal to, so we have to do 1 minus. Just like before, you're going to switch it to less than or equal to and take the number down by 1, and that's because here's 7, 8, 9. You want these numbers, so we've got to get rid of all these down here. So 1 minus the probability that x is less than or equal to 7. So that's 1 minus binom CDF if we have less than or equal to. So on the calculator, but don't make anybody sick moving this thing around. 1 minus second vars binom CDF. N is still 14, P is still 0.6, X, however, is now 7. We've changed it to 7, and you should get 0.692. For C, find the probability that 4 or fewer murders are committed with a firearm. 4 or fewer means X is less than or equal to 4. Well, that one's nice because the calculator can do this. It's less than or equal to, so we're going to do second vars, binom CDF, and we do N, which is 14, P, which is still 0.6, and X, which is now 4. And we get 0.018. So that one's binom CDF. Part D, probability that between 10 and 12 murders are committed with a firearm inclusive. So this is the probability that 10 is less than or equal to X is less than or equal to 12. This one is a little bit tricky because we can't do this on the calculator. The calculator can do less than or equal to. So what you do for inclusion statements, if you can find a chart with n equals 14, you can just add up the probabilities 10, 11, and 12. That's fine. If you don't have a chart, you're going to do the probability that X is less than or equal to something minus the probability that X is less than or equal to something else. So the question is, what goes here? So you have to think about how to change these statements so that they're both less than or equal to. So we have, if it helps you to write down, that's fine. We want these numbers, which means we need to get rid of all these 0 through 9. So we're going to subtract off the probability that X is less than or equal to 12. And some people get confused here and they put 13. If we do the probability of X is less than or equal to 12, that's what we want, which is fine. We want the probability of X is less than or equal to 12. Problem is that gives us everything less than or equal to 12, so it goes 0 through 12. So we start with 12, but then we get rid of 9 and below, and that will leave us with, if we take away the probability of X being 0 through 9, and we started with the probability of X being 0 through 12, we're left with 10, 11, and 12. So on the calculator, it looks really weird because but the calculator's fine. Binom CDF is just going to be a decimal. It's not going to be anything too strange. So what you do on the calculator, let me just write it here so you know. You do binom CDF, since it's less than or equal to 14, 0.6, 12, minus binom CDF 14, 0.6, 9. And the calculator's fine with that. Only thing I'll tell you is if you do it like that, don't forget to close your parentheses. Some people do the first one and hit enter and then do subtract where it does the ands minus, which is fine, but you can type it in all at once. You just got to remember to close that parenthesis. because all the time before I haven't closed them because it doesn't really matter. So make sure if you type this in all together, close the parenthesis, minus second vars, binom CDF 14, comma 0.6, comma 9. So you get 0.271. And like I said, you can do, I'm just going to hit second enter here and let me delete all this so you can see. If you do this and you leave the parenthesis not closed, that's fine. You can do it this way and hit enter. It'll give you that, and then you can hit minus and then do it again. You don't have to close the parenthesis. But if you type it in together, make sure you close that parenthesis. So otherwise it'll give you a wrong answer. Oops, hit the wrong button somewhere. Oh, comma, comma, and then 9. So it still gives us 0.271. So you can also do it that way. For the last question here, and then we've just got one more, find the probability that exactly 10 murders are not committed with firearm. So you have to pay attention to how these are worded. Some people think this means X does not equal 10, but that's actually not what it says. It says exactly 10 are not committed with firearm. Well, go over here. Not without a firearm, or not committed with firearm, that's actually talking about our failure, not our success. So this is still the probability of X equals 10, which we could switch to a Y value instead of X. But instead of using P, you have to use Q because it's talking about not being committed with firearm. So pay attention. If it says something like not equal to 10, then it would be not equal to 10. But if sometimes it's worded this way where it actually wants you to refer to the failure in Q rather than the success in P. So I know I said X and P always need to refer to the same thing, which is true. It's basically just so you know that whatever you're talking about here, it has to go with that probability. So generally speaking, you're going to be talking about success, and you'll always use P. So like I said, for this one, we could switch to a different letter just to indicate something else, but as long as you remember to use Q, it's okay. So we're going to do binom PDF so second var is binom PDF because we have an equal to. So N still 14. We don't use the P this time because it's not committed with firearms, so we're going to use 0.4 instead. And then 10. So we should get 0.014. And so for the last page, now this video is kind of long. It's hard to go through this too quickly. This talks about the Sunday Night Football broadcast between the Colts and the Patriots. There was 22% that were tuned in. An advertiser wants to do a second opinion, and they begin with 20 households. So, S, F, P, Q, and N. So success in this case is we're talking about whether or not they were tuned into the game. So success would be that they were tuned in, and failure would be that they did not tune in. Like I said, it doesn't really mean success and failure, just got to assign it something. So it tells you 22% were tuned in, so that goes with our P, so 0.22. Which means our Q, we need to add up to 1 or 100%, so this will be 0.78. And they're going to do 20 households to start with, so N is 20. So find the probability that none of the households are tuned in. That's the probability that X is 0. So we go to second vars. Oops, well shoot, let me close that and open it back up. Now that I didn't mean to. So we go to second vars, go to binom PDF because we've got is equal to, and we do N, which is 20, comma P, which is 0.22, comma 0. And you should get 0.007. The probability that 3 are tuned in, well, that's the probability that x is equal to 3. So again, we're going to do binom PDF. It's faster if you've already got binom PDF up there. It's faster if you hit second enter, and then you can just change from 0 to a 3. Then you don't have to go back through all that. So that one gives us 0.178. The probability that less than 5 are tuned in. So the probability that less than 5 are tuned in is strictly less than. So again, calculator can't do that. It has to do less than or equal to. So if you want to talk about numbers less than 5, you're talking about 4 and below. So we're strictly less than 5, which means we're less than or equal to 4. Once you switch to less than or equal to, you do binom CDF. So go to second, whoops, hit the wrong button, second vars, binom CDF, 20, comma, P is 0.22, comma, we switched from 5 to 4 because we needed less than or equal to. So you should get did I type something wrong? That's not what I got last time. 0.542. I did it a minute ago. It's not what I got, but I might have typed something wrong. So I don't see binom CDF is fine, and 20 in comma 0.22 comma 4. Maybe I used the wrong one when I did it a minute ago. The probability that 7 or fewer are tuned in. We're doing 7 or fewer, which is less than or equal to 7. So this one's already set up for the calculator. So again, if you want, you can just hit second enter. Change the 4 to a 7. So we should get 0.946. For the next one, the probability that at most 10 are tuned in. At most 10 means you can't go over 10, so that's less than or equal to 10. So if we go back again, you can do second enter. Switch 7 to 10. And you should get 0.9986 or 0.999. Find the probability that more than 11 are tuned in. So more than 11 is greater than 11. Now, like I said, anytime you have a greater than or a greater than or equal to, you're going to do 1 minus the probability that x is less than or equal to something. So the question is, what do you actually put here? So if it's greater than or equal to 11, you go down by 1 and put 10. But for strictly greater than 11, you want to keep the values 12 and higher, which means you need to get rid of 11 and lower. So if it's strictly greater than, you don't have to decrease by 1. You just do 1 minus the probability that x is less than or equal to 11. So we would do 1 minus the probability or 1 minus binom CDF. And we do 20, comma, P is 0.22, comma, 11. And anytime you get an E to the negative something, you can just do 0 plus because the decimal moves. The decimal moves 4 times, so you'd have 0.000266, which is just 0 plus. So if you write down 0 plus, that's fine. For the next one, 13 or more. 13 or more are tuned in is greater than or equal to 13. So in this case, you're going to switch it to 1 minus the probability that x is less than or equal to. This time it's greater than or equal to 13, so you want to include 13, which means you need to get rid of everything 12 and below. So you need to do 1 minus probability of x is less than or equal to 12. So we've already got the 1 minus and everything up here. So again, if you want, hit second enter. Change it to from 11 to 12. That one's also going to be 0 plus. You're going to move the decimal 5 places this time. So 0.000045, which is just 0 plus. Now H and I go hand in hand. It's the one I was talking about. You have to make sure whether or not it's talking about failure or talking about equal to or not equal to. Find the probability that 12 of the households are not tuned in. Not tuned in means we're failure and our Q is what we're talking about. So this is the probability that X is equal to 12 using our Q instead. So we're going to go to binom PDF. Oops, wrong button. Second vars and then binom PDF. And then you're going to do 20 is still the N. This time we're not talking about whether or not they tune. We're not talking about tuning in. We're talking about not tuning in. So we use Q, which is 0.78. And then X is 12. So we should get 0.035. And then I says find the probability that the number of households tuned in is not 12. So there's where your not equal to comes in. So you can see the difference. Not tuned in is failure, is not 12, is not equal to 12. Calculator can't do not equal to, so what you do is you do 1 minus the probability that it is 12. Because these probabilities have to add up to 1, so if we want not 12, we want everything but 12. So take 1 and subtract off what it is if it is 12. So we'll do 1 minus, second vars, binom PDF. N is 20, we're switching back to P this time. Normally you use P, the only time you don't is when you have a question like H. So 0.22 and then 12. And you should get 0.999. This rounds up to 1, but we usually don't write ones on here. So if 3 decimals round to 1, go out to 4. So 0.9998, it's almost 1, but instead of writing 1, just go out to 4 decimals. So that's how you do binomial distributions on the calculator. They're not necessarily hard. You just have to remember to change those inequality or equal to statements because the calculator can only do equal to or less than or equal to. So you have to rewrite everything, which makes it a little more difficult. That's usually the hard part. Once you get that figured out, you can just do it on the calculator, or if you want to use a chart for the ones you can, that's fine. So there's another sheet posted with more examples. It's got just the answers so that you can use that to do the homework. The homework, I think, is just 1 page, 2 problems. So one where it gives you a chart and one where you'd use the binomial stuff on the calculator. So just let me know if you have any questions.